Assalamualaikum warahmatullahi wabarakatuh. I'm going to present about the topic heat and temperature and also first law of thermodynamics. When we take a bite of an apple, we take the fruit's energy to be converted it to something that our body can use. So to better understand about how energy can be converted, we need to understand thermodynamics. Thermodynamics is focusing on converting thermal energy in forms of heat and work. We better start from Zeroth law to better understand about thermodynamics. This law focuses on temperature and defines thermal equilibrium. If two or more systems are in equilibrium, they are all at the same temperature. This is important because when a body is left in a medium at a different temperature, energy will transfer until thermal equilibrium is established. Two systems has reached thermal equilibrium. Zero's law of thermodynamics states that no net heat flow between two systems. Objects with same temperature will not exhibit heat flow when they come into contact with one another. If two objects at different temperature are brought in contact, they will try to reach thermal equilibrium. From the diagram, system A are in thermal equilibrium with B and are also in thermal equilibrium with C.
We have to bear in mind that when there is temperature difference, heat energy will transfer from hot to cold objects. In order to learn furthermore about this topic, we have to know what is temperature. Temperature indicates the amount of heat energy present of an object. Temperature measures the degree of hotness or coolness of an object. If an object possesses small amounts of heat, its temperature will be low. When an object is gained or lost energy, its temperature is increased or decreased. Energy transfer is shown by the temperature. Heat is a type of energy. Heat is transferred from highest temperature to the lowest temperature. Heat cannot be destroyed. It can only be converted from one form to another. From this picture, it is clearly shown on how energy is converted from the highest temperature to the lowest temperature. Next, we go to the topic of first law of thermodynamics. First law of thermodynamics is a general statement of law of conservation of energy. In a closed system, energy cannot be created or destroyed. It only transforms from one form to another. Internal energy is an energy associated with the seemingly random movement of molecules. Sum of all forms of molecular energies of a substance. Internal change in this equation, the change in internal energy is defined as is equal to the Q minus W, where Q is the net heat, while W is the net work done. We also have to take a look on the sign of convention. When heat is gained, the sign of convention is positive, while when heat is lost, the sign of convention is negative. Also occurs with the work, network. When work is by the system, the sign of convention is positive, while when work is on the system, the sign of convention is negative. So here is the thermodynamic process, which is isobaric, isothermal, isovolumetric, and also adiabatic. For the term iso, is defined as same. So here for isobaric, it has same pressure. Pressure is kept constant. So the it's kept constant. So the internal energy is equals to Q minus P, which is constant, bracket change in volume. Um, another part is isothermal. Another one is isothermal, which is constant in temperature. And other one is isovolumetric, which is constant in volume. And also we have adiabatic, which is no heat transfer in or out of the system, which means heat is zero. This happens when system is extremely insulated and the process happens so quickly. So the formula for internal energy is defined as negative work done.
When a system undergoes a thermodynamic cycle, the net heat supplied to the system from surrounding is equal to net work done by the system on its surrounding. This is applied on air conditioning system where absorption of heat by the refrigerant in the air conditioning system is equal to the net work done by the entire air conditioning system on its surrounding. According to the first law of thermodynamics, all energy must be conserved. Energy is conserved in a refrigeration system by having both an evaporation and condensing. Air conditioning systems are followed the concept of first law of thermodynamics, where evaporation occurs, which is liquid refrigerant at low pressure is brought into contact with the heat source. It absorbs heat and boils produce low pressure vapor, while condensing occurs when high pressure refrigerant gas carry the heat energy absorbed. Heat transfer will take place condensing the refrigerant from a high pressure vapor to a high pressure liquid. Oh, that's all for this presentation. I think I have made clearly about this topic and its application to our daily. Thank you.